Hello. In this video, we're going to cover section 2.2, which is on summarizing numerical distributions. The word summarizing in this context means to summarize the characteristics of the distribution. When summarizing a distribution, we look at the shape of the distribution, the typical value or center of the distribution, and the variability or the spread of the distribution. Typical value can be subjective, but usually means the center of the data. There are three basic characteristics of a distribution's shape. The symmetry, is the distribution symmetric or skewed? The number of mounds, do we have one mound, two mounds, or more than two mounds? The extreme values or outliers. Are there unusual values present in the data? A symmetric distribution has the left side of the graph and the right side of the graph as nearly mirror images. Symmetric distributions with the shape below are often called bell-shaped distributions. Okay, so they're talking about this one here. So this shape is called a bell-shaped distribution. A skewed graph has a long tail that extends to one side. The graph below is a right skewed distribution because the tail extends to the right. All right, so we're talking about this one here. You've got this tail here that extends to the right. An example of a symmetric distribution would be heights of women. So note, if you look at the distribution, it's not perfectly symmetric, but perfect symmetry is very rare in real data. But if you look, roughly speaking, if you were to hold a mirror up, you'd have the same thing on the left as you do on the right, and that's the case when we have symmetric distributions. Two more examples. So we're going to look at a right skewed distribution. So a right skewed distribution would be hours of TV per week. All right, so that's this guy here. And you can see that we've got a tail that extends off to the right. Okay, so what that means in terms of the data is that there's a large number of people who watch TV. It looks like about 12 hours a week is what we've got here. That's this peak. And then that tails off as we move to the right, and there's fewer and fewer people watching TV as you go to larger and larger amounts. Right? So we don't have very many people who watch 48 hours of TV per week relative to the number who watch 12 hours. Okay, and we have a left skewed distribution. In this case, it would be an example of test scores. This is a distribution that students would love to have in a class. Would be a left skewed distribution when it comes to test scores, where most people score very highly, right? So the test is out of 32. And so you've got a large number of people that are scoring, around close to the highest that you can score. And then that tailors off to the left. Right? So the last thing that you'd want in a class, in a test distribution, would be to have a right skewed distribution, right? Okay, so the number of mounds. So a one mound distribution is called a unimodal distribution. A two mound distribution is called a bimodal distribution. And if you have three or more mounds, then you'd call that a multimodal distribution. All right, so this guy here is an example of a bimodal. Actually, both of these are bimodal. We have one bimodal that is symmetric, and then we have a second bimodal, which is skewed. Looks like we have a right skewed distribution. Okay, so no examples here, but you could have one mound. You could have a distribution with just one mound. That would be unimodal. And then we could have a bunch. You could have a bunch of mounds as we moved along the distribution, and that would be multimodal. Okay, so here's an example of a bimodal distribution. What this distribution consists of is it's the finishing times for two marathons. Okay, so we've got two marathons of the same distance, okay, but one has one type of athlete. So we have, it actually doesn't describe the difference. Okay, so one marathon has elite athletes, like Olympic level athletes, and then one has more amateur level athletes. Okay, and so we can kind of see the two distributions here that are just linked together. And when you combine two groups like this, you often end up getting a bimodal distribution. So you can look and you can see the Olympic athletes really have one mound, so it's a unimodal distribution. And then the amateurs have one mound, it's unimodal. But if you combine the two, then you'll get bimodal. And that's very common. Like if you were to take heights of men and heights of women and you combined those, you would get a bimodal distribution. And yet each distribution individually would be unimodal. Okay, next we're going to look at extreme values. Extreme values are values so large or small that they do not fit into the pattern of the distribution. Outliers can be unusual observations or sometimes even mistakes in data entry, like a mistake, like an extra period there. And so if we go through and look at this case, this is a histogram of weights, right? And we've got all these people's weights here. And then supposedly there's someone who weighs 1,200 pounds. That is unlikely to be accurate. Most likely this was a mistake of data entry and that person was supposed to be 120 pounds and then they'd fit into the rest. Okay, now outliers are not always mistakes. That's just this case. So sometimes you can have unusual observations. So if you were to go back and say TV watching, I mean, there's probably examples of outliers of people who watch extreme amounts of TV relative to the rest of the distribution. All right, so the typical value. So the center is used when estimating the typical value in a distribution. If the distribution is bimodal or multimodal, then it may not make sense to have a typical value. Instead, it may make more sense to split the distribution into groups and find the typical value for each group. All right, so that's exactly what would be suggested in the example that we just looked at with the two marathon groups. If we were going to go through and try and find the typical value, which is kind of the center of the data, the center of the distribution, then it would make more sense to split those up into separate groups and then look at them individually. All right, so here we have a distribution of audience ratings for films in English. And if you were to go through and look at this, the idea is you just want to eyeball where the center would be, like what's roughly the middle of the data set. And if you kind of take a look at it, you've got this peak, right? So it doesn't necessarily have to be right at the peak, but the peak does look like it's pretty close to the middle. So we have a little bit of a lean on this side where it looks like there's a little bit more data on this side. So I would say maybe it's a little on the left side of this peak. So I would guess somewhere in this region here, toward close to 6.5. And so one way to go through and estimate this would just be to say 6.5 itself. But you could also say that it's between 6.5 and 7, close to 6.5. So you can go through and give those kind of details. That's okay too. But that's the idea, is that you look at it and you want to try and eyeball like where is the middle of the data in terms of the distribution. And then that's going to be what we call the typical value. So here's another example. This time we have the percentage of people who would pass the bar exam from a bunch of different law schools. Okay, and so if you look here, again, we have more data on the left side of this peak than on the right side. So I would say that the middle of the data looks like it's relatively close to 80, maybe 85. But definitely in the 80 to 90% range. So that's kind of a cop out that you can give it. You can say, hey, the typical value is somewhere in this area between 80 and 90%. But I would say because of all the extra data that's on the left, it's going to be more leaning on one side than the other. So the mode is the value that occurs the most often in the data. The mode is not a good choice for the typical value when it comes to numerical data for two reasons. If using a histogram, which is a common representation for numerical data, then the width of the bins can make a significant difference in the mode. So if you go through and you change the width of the bins, then suddenly the mode can jump around in the data set. There may also be many mounds within the data set, and then a small change in the data set could shift the mode from one mound to another, and that could cause the mode to jump around because of that. And so in both cases, these are the bad choices for the typical value. And the reason is that the typical value should be somewhat resilient to small changes in the data set or to changes in the bin width. All right, so let's look at a visual for those. So in this case, a small change in the bin width would shift the mode. So glance at this. The mode's going to be the tallest peak. That's the value that occurs the most often in this histogram. So right now the mode is right here. However, this is with bin widths of size 2. And if you do look at the bin widths of size 2, sorry, if you look at doing bin widths of size 4, then the two bins that are going to be combined to get from 2 to 4 would be these two. So you've got this tall one and this short one next to each other. And so you would end up looking at the next tallest bins to see where the mode would likely shift to. It would likely shift over to here. And so if we went through and changed the bin width from 2 to 4, the mode would jump from here to here. And that just shows that that's not a good example. If you change the bin width, the typical value shouldn't change. The typical value is still going to be typical regardless of how you present the data. All right, and then a small change in the data set could shift the mode from one peak to another. We can see that's the case here. So right now the mode would be at the top. It's again, that's the tallest peak. So the mode is right here. And if we went through and just made a very small change in the data set, if we went through and removed a couple of responses, so these are, what are these? These are critics ratings for English language movies. If just a couple critics ratings were different, then the mode would shift over to here. And again, so it would jump, and that's not good. All right, so you don't want to have, you want the typical value to be resilient to minor changes in the data. All right, if there is little variation in a data set, then we describe the distribution as being narrow. And if there is a lot of variation in the data set, then we would describe the distribution as being wide. So let's take a look at that. All right, so if a family has all the same height, so everybody's the same, very much a lot of sameness, which means there's small variation, then the result is going to be a skinny, or tall, or even tall. You could look at it both ways, a skinny, tall distribution, right? A single peak here. All right. And that's by comparison, if you have a family that has very different heights, then the result is going to be a very wide distribution because everybody's different. And so you've got some people, some members of the family are down here at 45 inches, some are at 55, some are at 65, some are at 75. And so a lot of variability ends up getting a very wide, distribution. So narrow distribution means a lot of sameness, small variation, wide distribution, large variation. All right, so if we can look at another example here, we've got public colleges versus private colleges. Okay, and so you think about public colleges tend to be less expensive. You rarely have public colleges that cost a great deal of money, and so because of that, there's kind of a restriction on how expensive public colleges can be, which forces them to be in a smaller variation. So you have a taller, narrower distribution as composed to private colleges where you have a much wider distribution. You have more variability. And you have some very expensive private colleges, and you have some inexpensive private colleges, that are similar to public colleges. And so that variation gets us a wide distribution. Okay, so that's it for the material. Now let's go through and look at some homework examples. So let's say we've got the weight of coins in grams as shown in the accompanying dot plots. And those dot plots were obtained for 2 different locations. And we're asked to go through and write a few sentences to compare the distribution of the weights of the coins from the 2 locations. And the things that they want us to do is they want us to mention the shape, center, and the spread. Okay, so let's try doing that, and then we'll go ahead and skip over to the next page. All right, so when it comes to the shape, the first thing that we think of is the symmetry. So this distribution does look relatively symmetric, I would say. If you held up a mirror right roughly around here, it's pretty similar to the left and pretty similar to the right. Meanwhile, this distribution is clearly skewed. You have some entries over here on the left, but a large number on the right. And so it kind of tapers off as it goes from right to left. So next is the number of mounds. And so if we look at this, there's many little peaks here, many mounds in this data set. Okay, meanwhile, this data set only has 2 mounds. So this one will be bimodal, and this one will be multimodal. And then the last trace for shape is outliers. Do these distributions have outliers? So they have values that are kind of unusual, that are separated from the rest. I would say that they definitely do, both of them. These 3 look like they're outliers to the first set. They're separated from the rest. And then these three would be outliers from this big group over here. And so they would be kind of separate. All right, and so next, what's next? We want to talk about the center. The center for this data set, I would guess, look, eyeballing is like maybe right around here. It looks pretty close to here. And then the center for this data set is pretty clearly at this big tall tower. How spread out are they? In terms of the spread of the data sets, they're actually pretty similar. So spread is just from that's kind of the smallest and to the largest. And so the fact that we have this big tall tower, it doesn't matter. Still, the spread is going to go from 2.7 to roughly 7.2, and this one goes from like a little bit below 1.8 to a little bit under 6.3. Just kind of eyeball this distance. The distance from here to here, and the distance from here to here are pretty similar. Okay, and let's take a look. So location 1 is relatively symmetric. That's what we noted. Location 2 is skewed to the left. Yep. Location 1 is multimodal, lots of peaks. Location 2 is bimodal. There's only 2. And then both have outliers, as we discussed. The center for location 1 looks like it's between 2.7 and 3.6. Yep, so I kind of cheated there and used a range. And then the location for center 2 looks like around 7. And then the spreads are similar, as we already looked at. Okay, here's another homework example. A teacher asks 90 students who drive to class how many speeding tickets they received in the last year. And then we want to go through and predict the shape of the distribution and then explain. All right, so if we go through and we think about speeding tickets are not terribly common. And so what we would expect is that if we talk to 90 students, that not very many of them would have speeding tickets. So we might have 80 students in that group who did not receive a speeding ticket. And so 80 students would have 0. That's a big group. That's most of the students who are going to have 0 speeding tickets. All right, and then next we would have some students who did get a speeding ticket, but not terribly many. So maybe out of 90, maybe you'd guess, 5, 6, 7 got 1 speeding ticket. And then in every class, there's probably some wild students who drive really fast and do get a lot of speeding tickets. And then they would have, and so you might have 1 or 2 students who have 2 or 3 speeding tickets. And so now think about the shape of that. So we have a big peak at 0, big tall tower at 0. And then at 1, we have a much shorter, a much smaller amount of people with speeding tickets. So it definitely falls sharply from 0 to 1. And then it continues to fall as you go to 2 and 3, and 4 and beyond speeding tickets. So if you think about the shape of that, peak on the left, peak at 0, which is the furthest to the left, shallow, falling, as it goes to 1, falling further as it goes to 2 and 3. All right, that is going to be a right skewed distribution. And then let's see, what did I write here? So speeding tickets are relatively rare. Most students are not going to receive a speeding ticket. However, a few will, and you'll have some with multiple. And then if you visualize the distribution, there's a tall peak at 0, then a significant drop to 1. And so we get a right skewed distribution. All right, let's look at a third homework example. So we've got 2 histograms here. They show the triglyceride levels for 82 men and 94 women. So if we want to go through, so the instructions are to compare the distributions for the men and the women. And in doing the comparisons, they want us to compare the shapes, the centers, and the spreads. And then the triglyceride levels under 150 are considered good. Levels above 500 are very high and maybe a health concern. And they want us to go through and ascertain which group has a better levels of triglycerides. Okay, so the shapes. So first, symmetry versus skew. It looks like we have right skewed distribution. So it kind of tails off to the right for the women, and tails off to the right for the men as well. Okay, the number of mounds, or the modality. We have, looks like there's 2 mounds here, 2 little peaks. So you could say that's bimodal. And then for men, we've got like 1, 2, 3, 4. This is multimodal. And then as far as outliers, do we have outliers? Yes, I would say this person is an outlier right here. That's high relative to the group, separated and off to the one side. And then we've got a couple outliers for men. This person's a very high outlier. This one as well. Now, you don't necessarily have to have a separation in the data. You can still have outliers even if there's kind of even if these are connected. So you could say at a certain point. I mean, I wouldn't say it in this case, but you could say at a certain point that this group is an outlier group as well, if it were much further away, right? So if we'd gone through and taken this group and, like, let's say you just took this picture and instead you had it here, but like there was like very shallow, I would say that then you'd have outliers. So you don't have to have separation. It's just much easier to identify it when there is separation. Okay, and then what's next? So the centers of the data. So the center of the data looks like the center is right around this 100 in this one. And then this one, I would say the same as well. This peak is tall enough that it kind of offsets these two. This one, maybe the men, I would say, is to the right side of this group. It's to the right side of 100. So maybe more like, 130, 140. It's kind of leaning over to the side. Whereas this looks like it's more closer to the center of this bar. But, you definitely could, again, you could kind of cheat and say, it's in this bar. Okay. The bar looks like it goes from, what's that? So this is 50. So it looks like it goes from 75 to 125. So you could say the center is between 75 and 125 for both. Okay, and then the spread. So which one, how do they compare when it comes to spread? So this one is spread. The spread goes from, it's like maybe 25, or the center here at 50 for this first bar up to 350. And then this one, somehow someone has 0. Oh, I guess that's probably just a very very low number of triglycerides for this guy. And then goes all the way up to this individual here, up at 750. And so the men are much more spread out if you were to go through and compare. So here's the women's spread, here's the men's spread, much more spread out for the men. And then which group has better levels? So high number of triglycerides is bad, according to this, 500 being very high. And we definitely have more high levels. So if you kind of just were to, this says 500 is very high, so maybe high is like 300. So you could maybe just estimate it there. Looks like we only have one woman that's above 300. Meanwhile, we have a bunch of guys that are above 300. And so it looks like the women's triglyceride levels are much better. All right, so let's look at what we wrote here. So both distributions are skewed right. That is correct. The women are bimodal, the men are multimodal, as we discussed. Both do have outliers, absolutely. The centers are relatively similar, around 100. The men's levels are more spread out, as we discussed. And then a larger percentage of men's values are high than women's. So then the women have better triglyceride levels. Let's look at one more example here. This is the last one. And what they want us to do is they want us to go through and match each description with the correct histogram. So the first one is quantitative SAT scores for 1,000 students who've been accepted for admission to a private university. The second one is weights of over 500 adults, about half of whom are men and half of whom are women. Sorry, that's supposed to be whom. And then ages of all 39 students in a community college statistics class that is made up of full-time students and meets during the morning. Okay, so what can we say about these before we look to the solution on the next page? All right, so when it comes to aptitude tests, and aptitude could mean anything from mental aptitude to physical aptitude. Typically, you get symmetric distributions. Often you get bell-shaped distributions. Again, that might not be something that you know when you want to do this problem in the homework. You can also go through and skip this one if you're not sure. But knowing that, knowing that aptitude typically is symmetric and somewhat bell-shaped, that kind of tells us that it would be the third one. But if you didn't know that, you could skip that one and come back to it, because I think the other two are more obvious. So we've got weights of over 500 adults, about half of whom are men and half of whom are women. Okay, so that's two groups. What did we say about two groups? Two groups, you're typically going to have a bimodal distribution when you do that. And so which of these is bimodal? It's A. All right, so you got a peak here on the left and then another peak to the right. And so I think it's kind of obvious because of that bimodal information we discussed previously, that number 2 goes with A. And then ages of all 39 students in the community college statistics class that is made up of full-time students. All right, so if you've got 39 students in a class, the class is in the morning, meets during the day, and the students are full-time, what are you going to be able to say about the distribution in ages for those students? I would say that the distribution is going to be pretty small. All right, so you're going to have relatively similar students, relatively young students in such a class. You're going to have relatively few older students, non-traditional students. And so what you would expect is you'd expect a distribution that is fairly narrow, like with taller peaks, right? So less variation, all right? So if everybody's similar, then you're getting less variation. That's going to be a narrower, taller distribution. So which is narrow and tall distributions? It's clearly B. Okay, and if you look at the distribution, you can see, oh, it looks like maybe we did have a non-traditional student, an older student in that class. All right, so number 2 is kind of pretty clearly A, and number 3 is pretty clearly B. And so by process of elimination, you could get that 1 is C if you weren't aware that aptitude is typically symmetric. Okay, and then I think the next page I just went through and wrote all that stuff up. Okay, so yeah, so we haven't covered this yet. Aptitude are typically bell-shaped. That's shape C. You can also answer this by process of elimination. Weights of men and women are likely to be bimodal since men and women are different sizes. That suggests shape A. And then same thing, what I said exactly about the distribution should be narrow and tall because there's going to be small variation in a class that's filled with morning full-time students. Okay, that's the video on section 2.2. Thank you for watching, and I'll see you next time.